Hello and welcome to today's lesson on equations and formulas. We're going to be looking at topics under the standard 1.1 in 8th grade, and we're also going to be looking under that lesson in Study Island called Equations and Formulas. So if you're working in either of the two places, these are some problems and lessons to help you out with that. This is part 2 of 2 videos going over that Study Island lesson, Equations and Formulas. And here we're looking at problems where they give you the formula and how you can use those to answer the question. So glad that you're joining us today. And remember, as you're going along, please be taking notes. They're only going to help you and it'll give you something to study. And then also remember to stay up with those notes. You can pause, rewind, or fast forward the video at any point. And you can also pause at the beginning of the question, work the problem out, and then see how you do. And that way you can get a gauge on how well you're doing or where you still need to learn. So thank you for joining us today, and let's go ahead and look at some problems.
Ernie is taking a walking tour while vacation in London, where the forecasted high temperature is 35 degrees Celsius. Using the formula below, where F is the temperature in degrees Fahrenheit and C is the temperature in degrees Celsius, to find the forecasted high temperature in degrees Fahrenheit. So over in England and Europe, they use Celsius to measure their temperatures, where we use Fahrenheit. So in order to convert that so that the number makes sense to us, we are going to have to use this formula. So this C here is what the number they give us, 35. So that means that in order to find the Fahrenheit number, I'm going to have to replace that C with a 35, or substitute 35 in for C. And then I just have to follow order of operations. Multiplication is before addition, so I'm going to multiply these fractions. And just a little hint, when you're multiplying fractions, is you can cancel any bottom with any top. So I see I can reduce this 5 and 35 to 1 and 7 by dividing both of those numbers by a 5. And that's just a little trick that makes the numbers a little smaller to work with. And so when I multiply fractions, I'm going to multiply the tops by each other and the bottom. So here 9 times 7 is 63. And then on the bottom, that's 1 times 1 is 1, plus 32. 63 over 1 is the same as 63, so this is really just 63 plus 32, which is 95. So that means that 35 degrees Celsius, that sounds kind of cold to us, but that's actually 95 degrees Fahrenheit. It's pretty warm over there today. So that's going to make my answer C. Number 2 says Leo ran a 10-kilometer race in 75 minutes. Use the formula D equals RT and 1 kilometer equals 1,000 meters to find the average rate at which Leo ran. Round to the nearest tenth of a meter, but per minute if necessary. So here we're given a number that's kilometers and a number that's minutes for their unit. But our answer needs to be in meters and minutes. So that means the first thing I'm going to want to do is to convert this 10 kilometers to meters. So the way I'm going to do this is I'm going to set up a proportion. So 10 kilometers, I want to know how many meters that is. And so I'm going to set that equal to, and here's my conversion, that's 1 kilometer is the same as 1,000 meters. And now keep in mind, when you set up a proportion, you always have to have the same units on the top as the bottom. So here's my meters, and that's what I'm looking for. And then you also want to make sure that the numbers on the same side are the ones that are related. So 1 kilometer is the same as 1,000 meters. And I'm finding out what's the same as 10 kilometers. So make sure you keep everything lined up and down and across. And so now I'm going to cross multiply. I'm going to put an x here. And it's going to have 1 times x, which is 1x, or just x. And then 10 times 1,000 is going to be 10,000. So that means that 10 kilometers is the same as 10,000 meters. So now that I have this in the right units, and I have my 75 minutes, I'm going to go over here and use that formula, D equals RT. Okay, and this is something you might want to write down. If you need to pause, do so. D stands for distance, R stands for rate, and T stands for time. So there, I wrote it out for you. And so now I know that the distance is this 10,000 meters. That's how far. So I'm going to put or write 10,000 equals. Your rate is your speed, and that's what I'm looking for, meter per minute. That's a rate. So I'm not going to leave my R, and that's going to be times my how long, my time number, which is 75 minutes. And then I just have to solve for R. So this is R times 75. The opposite of multiplying is dividing. So I'm going to have to divide both sides by 75, which I'm going to have to go over here and set this up as long division, which looks like this. And then so 75 goes into 100 one time. So 1 times 75. And then 100 minus 75 is 25. Bring down that next 0. 75 goes into 250 3 times. And this is just, I've done this problem, I've worked with a lot of multiplication problems in life, so I can kind of do this in my head. But if you needed to, go over and decide and try out what 75 times 3 is. And 75 times 3 is 225. Which when I subtract those, that leaves me with 25. Bring down the next 0. And then it's 250 again, so I know that's going to be another 3. And then, so I'm going to take 3 times 75 is 225. And doing that subtraction, that leaves me with 25. It wants the nearest decimal, nearest tenth, so I need to go out 1 decimal. So add in my decimals, bring in another 0, bring that down, and then it's going to go in 3 times, and then it's going to be that same minus. And then this is going to be my answer, which is B. Because remember, you have to be able to do the long division because you can't use a calculator on your test. So here we have 2 fish that are 6 feet apart, starting to swim away from each other in opposite directions in a river. One fish is traveling at 2 feet per second, and the other is traveling at 5 feet per second. You're going to use the distance formula, distance equals rate times time, to find how far apart the fish are after 9 seconds. So I'm going to draw a picture to help me. So I have these 2 fish. And they start out 6 feet apart. You have one fish that's traveling at 2 feet per second. And you have another fish that's traveling in the opposite direction at 5 feet per second. And they travel 9 seconds. So I have to see how far each of these fish can go in 9 seconds. So I'm going to use my distance formula for that, which is D equals RT. And I wrote it down on each fish's side because I'm going to have to figure out for each fish. So I'm looking for the distance. So I'm going to go ahead and write down D. This fish is going at a rate or speed of 2. So put a 2 in for R, and then it's 9 seconds is my time. So 2 times 9 is 18. So this fish goes 18 feet in 9 seconds. And then I'm going to do it for my second fish. And once again, I'm looking for my distance. This fish's rate is 5 feet per second. So it's going to be 5 times 9, that same 9 seconds from before. 5 times 9 is 45, so that means this fish goes 45 feet in 9 seconds. So to see how far apart they are, I'm going to have to add the 18 plus the original 6 they were apart plus the 45, and then 18 plus 6 plus 45 is 69 feet, which is my final answer, letter B. Another formula you could see is the interest formula, which is this right here. So this problem says Nelson invested $500 in a certificate or deposit that pays 5% simple interest when it matures according to the formula below. So in this formula, I represents the interest, P represents the money invested or principal amount, I is the simple interest rate, and T represents the time in years that the money is invested. And so now, if Nelson will earn $50 in interest when the certificate of deposit matures, how long will it take it to mature? So I have these three values that I have to see which ones do I know and which one am I solving for. So here, Nelson invested $500. The P is the amount of money invested, so that means my P here is going to be 500. Okay, the next number I have here is 5%. It's simple interest. And so R is the simple interest rate. So that means my R is going to be 5%. But remember, you have to write that as a decimal, and 5% is the same as 0.05 or 500. So my R is going to be 0.05, which is the same as 5%. Okay. And then here it tells us he will earn $50 in interest. I represents the amount of interest, so I is going to be 50. And then how long, that's going to be my time. That's what I'm going to be looking for. So now I'm just going to substitute it into the formula it gives us. It says I equals, so that's going to be 50 equals the principal, the P, so 500 times the rate, which is 0.05, times the time. So I'm going to have to do 500 times 0.05. And so I'm going to do 5 times 0 is 0, 5 times 0 is 0, and 5 times 5 is 25. And since that number, that 0 there, 0 times anything is 0, it's not going to change anything. And there's nothing after it, I can go ahead and skip that step. But if it feels you more comfortable to work it through, go for it. It doesn't hurt anything, it's just extra. And so remember to find out where the decimal goes in multiplication. You're going to have to count how many decimals there are to the left, to the right of the decimal in your problem. So this one has 0. Here I have 2. So I have a total of 2. So that means I'm going to have 2. I'm going to put the decimal right here so that there are 2 decimals after my answer. So my answer is 25. So that means I'm going to have 50 equals 25t. So that's 25 times t, so the opposite of that is dividing. So I'm going to divide both sides by 25. And then 50 divided by 25, 25 goes into 50 twice. So this is going to equal 2 equals, and these cancel, and I'm left with t. So that means it's going to take 2 years to earn that $50 in interest. Here, Zelda invested $400 in a savings bond that pays simple interest according to the formula below. In the formula, I represents interest, P represents the money invested or principal amount, R represents the simple interest rate, and T represents the time in years that the money is invested. If the savings bond pays 5% interest, how much interest will Zelda earn after 10 years? So once again, I have to identify what I know about the different variables. So I'm going to write down I, P, R, and T, and then write down what numbers I know for each of them. So make sure you're doing the same. So here, Zelda invested $400. P is the money invested, so that means 400 is going to be my P. Okay, there's one number. And then I also have 5% interest. And so anytime I have a percent, that's going to be the simple interest rate. Now I can't write down a 5 because that's a percent number. I need to convert that to a decimal first. So 5% as a decimal is 0.05. Remember, you just, when you're converting from a percent to a decimal, you move the decimal twice to the left, and then I had to fill in the 0, so that's where I got my 0.05. And then it's after 10 years, years is time, and so in time here is always in years, so t is going to be 10. And so it says how much interest, so that means I'm looking for I, which represents the interest. So I'm just going to substitute in what I know. I don't know I, so I'm going to have I equals the principal amount, which is 400, times the rate, which is 0.05, times t, which is 10. So I just use this formula up here. And then you can multiply in any order when you have all multiplication. So I'm going to take this 0.5 times 10 first, because I know anytime I just multiply by 10, it moves the decimal once. So it's going to be times 0.5 now. And then I'm going to have to go over here and do 400 times 0.5. 5 times 0 is 0, 5 times 0 is 0, and then 4 times 5 is 200. I have to count out how many decimals I have to the right. There's 0 here, there's 1 here, so that means in my answer I'm going to have one number to the right of the decimal. So that makes my number here 200. He's going to earn an interest after 10 years, and that makes my answer A. If you didn't know that you could just move the decimal once for this little trick over here that I explained, that's fine. You could just have to work it out like this twice. Next question says, Starla bought napkins at an Atlas store for $1.75 each. She also used a $15 off coupon. If Starla paid $11.25 before tax, how many napkins did she buy? Well, this one you kind of have to work backwards. So she paid $11.25, but her original price had $15 off of it. So I'm going to add that $15 back on to see what her original total was. And her original total was $26.25. And then since each napkin was $1.75, which they better be pretty stellar napkins for that price, we're going to have to divide that original total of $26.25 by $1.75. And remember, when you're dividing by decimals, you need to get this number here to have no decimals in it. And you just do that by, if I'm going to move the decimal here twice, so I have to remove the decimal here twice, and I'm going to have a new division problem of 175 divided by 2,625. Remember, it's okay to have decimals underneath the dividing sign, but you don't want to have decimals by your divisor. So, and you just move them by the same amount. And here it worked out that both decimals went to the end. So here 175 divides into 162 once. So 1 times 175 is 175, and then I subtract those, and I get that this is 87. And then I bring down my 5, and then 175 goes into 875 5 times. And so if you weren't sure on that, you would just go over here and work out a couple of multiplication problems. 5 times 175 is 875, so when I subtract that, I get 0. And so that means I have no remainder, and I'm done. I don't have any more numbers to bring down, so that means that she was able to buy 15 napkins for my final answer of A. Thank you for joining us today, and I hope you learned something new.